So we got 5 pieces now, 3 givens, we found 2 others. We need side C. Don't use Pythagorean theorem because we don't have a right triangle here. So we got to somehow find this guy down here, which means we have to use lambda. So sometimes you can get away with not using answers you've created, okay, and other times you can't. So we're just going to have to use this. So I'm going to say sine of lambda, which was 80, over side C, which is what I want. Okay, now I need to pick one of the 2 things to set it equal to. Okay, you don't have to do both, just pick one of the 2. I'm going to use this one because it was given to me. I have A and I have A here. Okay, we do the math here and solve for C. Throw it in your calculator, you can see over there, and C comes out to 9.8. You take a minute and you check and see if everything makes sense. So angle C was 80, side C was 9.8. Angle B was 70, side B was 9.4. So because angle C is bigger than angle B, side C should be bigger than side B as well. There's your 3 missing things. Get them all nice and boxed up and labeled so I can clearly read them. Next, it's an angle side angle example. Okay, they give you the triangle again, so we know we can trust the scales and the dimensions for that. And we want to solve this thing again. So we take a look what we're given. Angle A, angle B, automatically I'm finding angle C here. It's got to be 100 degrees. Okay. They also give me side C. I can look at this picture here. I can go throw in this as 100 degrees as well. Now they give me this 12, so I'm going to have to use that answer there, so make sure it's correct. So I'm going to say sine of 100 over side C. Now it's really up to you whichever one you want to find next. Okay, but we don't want to set 3 different ratios up. We only want to do one at a time. So I'm going to use the 60 with the B. So sine of B over side B. Now we solve this. Comes out to 10.55. We check and see if that makes sense. Angle C was 100. Its side was 12. So an angle B of 60, it better be less than 12. Comes out to 10.55. Okay, last thing we need now is to find side A. So I'm going to keep the same thing that I did before with C and C here. Now I'm just going to shift it to A. So you guys can see the work over there in the calculator. Make sure you understand what I'm doing. Just a simple algebra 1 problem there. So 12 times sine of 20, and then divide that guy by sine of 100. A comes out to 4.17. I take a look at the answers I got, and I see if they're reasonable. A was the smallest angle, so A should be the smallest side. B is the middle angle, B should be a middle side. Things look pretty good. There's all the work there if you want to see it, how the book kind of presented it. Okay, next it asks us to solve this triangle here. Now it's a side-side angle, okay, but again, I don't really care about those types of things. They don't have a picture. You could try and draw a picture, but whatever you get as your answer may not always agree with your picture, okay? So instead of a picture, I'm going to look at what I have. B and a B. So I know I have to use sine of 50 over 3. The only other thing I'm given here is side C is 5. That means sine of lambda must come up top here as well. So we go to solve this. So we're going to take 5 sine of 50 We're going to divide that by 3. So what happens, sine of lambda equals 1.27. Now we say, okay, well, I want to solve for lambda, so I try and inverse my answer. Error domain. So what we're trying to do is trying to find where the sign is 1.2. Signs only happen from -1 to +1. So what this is this is a no triangle. You cannot make a triangle with the measurements they gave you. Okay, the math backs it up, so that's why I'm saying a picture may be difficult. Okay, so trust the formulas and see what happens. If you did try and make a triangle, it looks something like that. The sides would never match, so it doesn't work. Lastly, here is this guy. Okay, so this is another side-side angle example. Okay, they're kind of giving us the same types of things again, but the numbers should work better for us. So I'm going to set this guy up. Notice I switched to sine of C here. Sometimes I do that. It just helps me keep track of things because we don't use the lambda as often as we do alpha beta. Okay, so we keep that guy there. We go ahead and we solve for this. When we do, what we find is the sine of C comes out to be 0.3. So we say, okay, it's in between -1 and 1, so that's good. So I can do an inverse sine of that and find out where I'm at. Now the nice thing is we're in degrees, so these numbers will make sense to us. Okay, so don't round that to 17 or 18. Keep that at 17.5. Okay, so we keep going here. We say, okay, once I got my lambda, I have my beta is 30. I got 2 of the angles. I can go find the other guy. So I'm going to say 180 minus my answer there, minus the 30 degrees I already have given for angle B. Tells me angle A is 132.5. Only thing I'm missing now is side A. So sine of A over the side. Now you get to pick one here. I'm going to go with the given because I know it's going to work. So I do the math. You can see it on the calculator there. A comes out to 7.37. So we take a look at our answers and we see if they make sense. So angle A, by far the biggest, that side came out to 7.37. Okay, it's bigger than the other two sides, so that's good. Side B is bigger than side C, so angle B better be bigger than angle C here, and that looks good. Now the only trick with this is, when we had this right here, sine of C equals 0.3, that happens 2 places. We found it at 17 degrees, but it also is the exact same thing at 162. It's just like sine of 30 is the same thing as a sine of 150. So this is where you've got to start checking for some double triangles. So we did everything we did before, and that looks great. But you're going to have to remember to go back and say, okay, I could also have an angle C of 162. But the only problem with that is, if I already have this guy at 30, and I think I can have one at 162, that doesn't leave room for a third angle. And that leads us into that ambiguous case where we actually do get 2 triangles, which we'll start looking at tomorrow. Here's kind of all the work again. Big note here, anytime you're finding angles, you need to check to see if 2 triangles can be drawn. Okay, so anytime you're inversing them, just start getting in that frame of mind.